So, hello guys. So today I want to, do something very interesting. So there's this new tool I found that has been very powerful, especially for students. And quite honestly, I try to, kind of neglect it too and see it as just a normal thing everyone should know. But then some weeks ago, I was speaking with a friend, and I asked him about this too. I was like, for example, trying to cite it in an instance, saying, for example, look at this tool that is helping everyone. And he's like, he has never heard of that tool before. So that was the point I said, really? Are you serious? You've not heard of this tool? He said he has not. So today I'm going to be talking about um, Notebook LM. That's the name of the tool. Let me update something real quick. So I'm going to do a demo of Notebook LM, a full demo. So I'm going to test it out in real time. I'm going to show you what it's like using this powerful tool because it's one tool that I've been using as a student to prepare for exam and to do different stuff, and really has been very powerful. And there's been a lot of has made it blow my mind so far. So in a few seconds, that is, I'm going to be uncovering that. So without much ado, let's get on it. So I'm very excited. So I've used this to prepare for an exam, um, a medical exam for that case. So, and it's what amazes me is how much vast value it has, um, how much it can do. It has um, so much value in just one tool that at a point I was like, really, this because it's insane value. It's insane value. I can't lie to you. So here is two, and let's get on it as quickly as possible. Okay, right, beautiful. So it says understand anything. So we're gonna try it. I'm gonna try it. Okay, I think I have a Google account. All right, let's try Notebook. So it's a Google product, and for the most of it, I found it to be very interesting. Very interesting. You can't believe what I've done. Here you can see some of my recent notebooks, hemoglobin types. I have an untitled notebook. Second physio. This second physio was an exam I took in March last year. So it's quite free for the most of it. Quite free. Um, I could almost do everything with a free account. So that's how free it is. And also, I heard that you can. Oh, think. Sorry, I'm not gonna sign into the account. So for most of it, I think it's free to uh, students in the US. It's free to use for them, and yeah. So let's get on it. So I'm going to create a new notebook. So it's quite simple. you just drop in a link of the source of the information you want to provide it with, and then it's going to summarize it for you. It's going to, tell you what is in that material. And as you can see here, you can upload from your Google Drive, your Google Docs, or your Google Slides. It has an option for that. So wherever you have in your Google Drive, you can upload it directly to this place. Also, it gives you the option to send in a link of a website or a YouTube video. So once you just paste in this link, it's going to summarize the lesson, and it's going to tell you whatever is spoken of in that particular lesson. Hi, welcome. Welcome to the live. It's nice seeing you. So it's going to summarize everything. Also here you can paste in copy text, and here you upload all the sources you want to. So I've the last time I used this, I uploaded a voice note from WhatsApp, and it was shocking. It was amazing at the comprehension, because he was able to I think, should I try something like that? Let me see if I'm going to see a note. Like, if I'm going to see a note, like, there was a voice recording of a lecturer just gave a voice recording, and Notebook LM was able to you know just break it down at an instant and give the content of the material. So it's obviously there were errors in the transcription, but then I was able to, after breaking it down, breaking out the errors in transmission and everything, he was able to, you know, make it, he was able to um, take it apart essentially, and auto correct all the mistakes made. So I'm going to upload the sources. Documents. Okay, it's not here. I'm trying to upload the sources. I'll go to documents. I'll go to Notebook LM. Oh shit. Yeah, that's it. So I'm going to upload the first document. So as you can see, this is a medical. Really, the file type isn't supported. Are you kidding me? So sorry, guys. I should have. Okay, this is a PowerPoint presentation, which means I'll have to convert it to a PDF for it to work. All right, I'm going to get something we can use. We can work with this PowerPoint presentation, but then it's going to be, a bit hard to work with it. So I'm just going to save us the stress and find something else. Just a minute. All right. So you are like this. I can be moved in silence. Okay. So I've actually found something, but then okay, I think this is gonna be good. And one more thing, one more thing, one more thing. Hematology. Okay, this is a voice note. I think this is just proving too hard. I don't know. All right, we're gonna work with what we have. Okay, let's just work with what we have. All right, so this is hematology past questions and answer, and this is a note on sickle cell anemia. So hematology, sickle cell anemia is basically, a part of hematology. So I've uploaded the notebook, and as you can see, it's coming up with a summary. So here it says hematology past questions and answers, and it reads: the provided text comprises excerpts from a hematology question and answer document addressing various aspects of blood and bone marrow physiology, pathology, and diagnostic methods. It clarifies common misconceptions regarding the blood supply to bone marrow and the characteristics of hematopoietic stem cells, along with the roles of specific cells within the hematopoietic microenvironment. The document further details erythropoietic processes, red blood cell metabolism, and iron absorption. Hmm. Before moving on to different types of anemia, hemoglobinopathies, and myeloproliferative disorders. Finally, it covers diagnostic criteria and treatment approaches for conditions like myelodysplasmic syndrome, chronic myeloid leukemia (CML), and multiple myeloma. Okay, I don't think I've been able to pronounce that well too. And concludes with information on hematopoietic stem cells transportation, the properties of specific therapeutic agents, and the causes and management. All right, this is beautiful. So, um, here I'm going to try to show you an kind of an overview. Yep, I just hope you can see that. Okay, so here there's actually a mind map. So currently I'm generating a mind map. I don't know if you can see it on the screen of the document. Mm, I'm generating a mind map of the document, and also a video overview and an audio overview. So I think the mind map is ready. So here is a concise mind map for you to follow when studying this material. So this is so beautiful because um, if you are the kind of person that you function better reading with graphs and mind maps, this can quickly help you to grasp the topic. So I'm going to open up all the mind maps, the full map, so you can see how far it goes. I don't know if I'm able to I'm gonna be able to open up all of this, but then I'm just gonna open up as this is quite huge. This is quite huge. Can't even open up all of one of it. Oh my god. Okay, I think I minimized it. Uh, so this is just a very minute. This is just a very minute part of it. Hmm. All right. So this is kind of how the mind maps looks like. This kind of it's because the material I uploaded is very huge. So the mind map kind of contains everything. It's a past question and answer. So it tries to touch all the topics. Um yeah. But I'm gonna minimize this and then we are going to review other things. The video is not done generating, the audio is also not done generating. The other is also not done generating. So basically, um, so once again, this is Notebook LM, and I found it to be a very useful tool for studying. So if you're a student, if you do research, I find it as a tool. I don't know why Google does not promote Notebook LM as much. I don't know why, because this is practically one of the best resources that I have seen. So this is the source guide. Um, I don't know if you guys can see this part. Okay, I'm gonna shift this a bit so you can see this part. So it says this document serves as a comprehensive question and answer. This is the document I uploaded. The one for the past questions serves as a comprehensive question and answer guide concerning various hematological concepts, distinguishing between correct and incorrect statements, covers fundamental aspects of bone marrow and physiology, detailing the primary blood supply, where the nutrients artery, and blah blah blah. So it's just summarizing the material I sent. So it's just so simple. It's as simple as you upload the material and it summarizes it into tiny bits, and you can literally tell it to do anything and it's gonna do it literally, because I'm joking with you. So this is how big the material is. Let's try to look at it. The major blood supply to the bone marrow is hemisphere artery. False. The major blood supply to the bone marrow is via the nutrient artery, which enters the blood through the neutron former, then branches into longitudinal arteries and capillaries. Hemisphere veins drain blood, but hemisphere artery is not the main supply. Stem cells are CD34 plus CD38 plus false partially. So basically, this is a med school exam, and not just any material. So I had to find like the toughest of materials to give it. I like to find like the toughest materials to give it and make it to try to summarize it and tell us what it's about. So it's as good as that. So let's go back to this is hematology and sickle cell disease. And of course you can see there's from the top there's bone marrow fundamentals, there's erythropoiesis, there's RBC metabolism, there's iron metabolism, there's malabsorption syndromes, micro yeah microangiopathic hemolytic anemia, sickle cell disease, hemoglobin erythropoiesis migration, myo myelo myeloproliferative disorders, it is and what's not. I'm gonna close this tab. I'm still waiting for it to be done generating the video so I show you guys exactly what the video looks like. All right, so it's done generating the audio. I'm gonna play the audio for you guys in a bit. So here's the audio. It's done generating the audio. Let me increase the volume of the desktop audio. In a bit, I'm gonna play it. Yeah.
Welcome, deep divers. Get ready because today we're plunging into the incredible, really vital world of hematology.
So this is a 26-minute audio summarizing everything in the because it's a past question. It's a whole past question. It's a whole lot of materials, and this is the audio overview of the whole material. This is a med school exam preparation material.
Welcome, deep divers. Get ready because today we're plunging into the incredible, really vital world of hematology. We're talking blood.
That life-sustaining river flowing through all of us.
Exactly. And we've got a stack of sources here, and we're going to pull out the key nuggets, separate, fact from some common myths, and really get to the why behind how our blood works. Okay, so let's unpack this. We're aiming to dive deep into the intricate details from where blood starts in the bone marrow.
Right, the very beginning.
All the way to complex diseases like sickle cell. And pull out some, frankly, surprising facts. The mission. Give you a shortcut to being really well informed on a fascinating topic. So, first up, bone marrow.
The factory, right?
Yeah.
For all our blood cells. Now, I think many people assume it's got a pretty straightforward blood supply, but it's actually more interesting.
It is, yeah. There's this common idea about an emissary artery being the main supply, but that's not quite right. The major lifeline is actually the nutrient artery.
Nutrient artery, okay. Yeah, it finds its way into the bone through a little opening, the nutrient foramen, and then it just branches out extensively. Make sure the marrow gets everything it needs. Emissary veins, they handle drainage, sure, but the supply side is all about that nutrient artery.
Got it. So the nutrient artery is the key player there. And inside this busy factory, what about the fundamental building blocks, those really versatile stem cells?
Ah, right. Well, for the true pluripotent hematopoietic stem cells, the ones that can become basically any blood cell type, we look for a very specific marker combination.
Okay, what is it?
It's CD34 positive and CD38 negative.
Negative. So the absence of CD38 is the important part.
Exactly. That negative marker is, well, it's crucial. Its absence is what really tells us it's one of these master cells, distinguishing them from the more committed progenitor cells. Those ones would be CD34 positive and CD38 positive.
Ah, I see. So it's a subtle difference, but really important for identifying the true starting point.
Very important, yeah.
It sounds like the marrow isn't just like a hollow space. It's a whole ecosystem in there. People might picture it as just scaffolding, but it seems much more active.
Oh, absolutely. It's a mistake to think of cells like macrophages and reticular cells as just, cement structures. They're incredibly active, vital parts of the hematopoietic microenvironment.
There's a long audio of 20-something minutes. let's play the video. This one is the video overview. Wow, this looks amazing. 7 minutes video. This is 7
So,
minutes.
today we're going to dive into this incredible story of how one tiny, tiny change in our genetic code, literally a single letter being swapped, can completely rewrite the destiny of our body's most essential workers. We're going to follow the journey of a single red blood cell to really understand the huge and often painful impact of sickle cell. I want you to picture this. Millions of delivery trucks, all trying to squeeze down a single lane road at the same time. It's chaos, right? Well, that is the core problem we are exploring today. This simple question. It gets right to the heart of what a sickle cell crisis is, a biological traffic jam with just devastating consequences. Okay, first up, let's meet our main character, the humble but absolutely heroic red blood cell. Its mission might seem simple, but believe me, it is absolutely critical for our survival. Think of the red blood cell as the ultimate courier service. I mean, each one is this super flexible disc-shaped vehicle, and it's loaded with the most precious cargo you can imagine, oxygen. It grabs that cargo in the lungs and then has to navigate this huge network of our blood vessels to make sure every single organ, every muscle, every tissue gets exactly what it needs to function. So how do these little couriers fuel their journey? This is what's so clever. Unlike almost every other cell in your body, they don't have the usual power plants, the mitochondria. Instead, they have this really unique system that lets them generate energy without using a single molecule of the oxygen they're carrying. It's the perfect design for a delivery service, right? It never ever dips into the cargo. So where do these incredible couriers even come from? Let's take a trip inside the factory where they're built to see how this whole amazing process works. Every single red blood cell you have starts its life deep inside your bones, in the bone marrow. And here's a cool little detail. That factory is powered by what's called a nutrient artery. It actually plunges deep into the bone itself just to fuel this constant life-sustaining production line. And within this factory, you've got these specialized little nurseries called erythropoietic islands. Right at the center of each island is a big macrophage cell, and it acts like a nursemaid. It provides iron, it provides crucial growth signals, basically nurturing all these young red blood cells as they develop. And this path to maturity is unbelievably precise. The cell starts out as a pronormoblast, and it goes through all these different stages, just packing itself fuller and fuller of hemoglobin. But the most dramatic step? It's right near the end. The cell literally ejects its own nucleus just to make more room for oxygen before it finally squeezes out into the bloodstream ready for its mission. But what happens when there's a tiny, tiny error in the blueprints for this cell? Well, this is where our story takes a really dramatic turn. A single spelling mistake in the genetic code, and it changes everything. The problem starts at the most fundamental level you can imagine. A single point mutation. One letter is changed in the DNA sequence in the gene that's responsible for making a key part of our hemoglobin. And this tiny genetic change leads to a crucial substitution. In the protein chain, an amino acid called glutamic acid gets swapped out for another one called valine. It sounds so insignificant, right? Just one little molecular swap. But you'll see, this changes the entire game. And the consequences are just profound. See, normal hemoglobin, it stays nice and flexible, which lets the cells flow freely even after they drop off their oxygen. But this altered sickle hemoglobin, it does the exact opposite. The moment it releases oxygen, it starts to harden into these rigid rods, forcing the whole cell into that distinct and very dangerous sickle shape. Now, this change in shape isn't just a one-and-done deal. Oh no, it kicks off this dangerous, self-perpetuating cycle that can quickly spiral into a full-blown crisis. This sickling process doesn't always happen out of the blue. It's often set off by specific triggers. Things like an infection, getting dehydrated, or even just being exposed to cold can cause huge numbers of these cells to change shape all at once, leading to a system-wide traffic jam. Okay, before we go any further, it's really important to clarify some terms here because it can get confusing. Sickle cell disease is the big umbrella term for all the related conditions. But sickle cell anemia refers specifically to the most severe form, where a person inherits the sickle cell gene from both parents. It's a really key distinction. So, when those triggers cause widespread sickling, the result is a medical emergency known as a sickle cell crisis. And these crises, they can actually show up in several different and very serious ways. Crises can take a few different forms. The one we hear about most is the vaso-occlusive crisis. That's what causes that terrible pain. But there are others, like an aplastic crisis, where the blood factory itself just temporarily shuts down, or a sequestration crisis, where blood gets dangerously trapped in an organ like the spleen. Let's focus on that vaso-occlusive crisis. Because the sickle cell shuts down, or a sequestration crisis, that's what causes that several different and very serious ways. Crises can take a few different forms. The one we hear about most is the vaso-occlusive crisis. That's what causes that terrible pain. But there are others, like an aplastic crisis, where the blood factory itself just temporarily shuts down, or a sequestration crisis, where blood gets dangerously trapped in an organ like the spleen. Let's focus on that vaso-occlusive crisis. Because the sickle cells are so rigid and sticky, they just can't squeeze through the body's tiniest blood vessels. They get stuck. They create a log jam that blocks blood flow completely. And the tissues downstream, they're starved of oxygen, which causes excruciating pain and, over time, really serious organ damage. All right, let's look at a little clinical puzzle. A lab machine might spit out a really high white blood cell count for a patient who's in crisis. But often, the real number is something lower, maybe like this, 11,200. So what in the world is going on here? Well, it turns out it's a case of mistaken identity. The bone marrow is working so hard to pump out new cells that it starts releasing some immature red blood cells that still have their nucleus. And the automated lab counters, they see that nucleus and they mistake them for white blood cells, giving a totally false high number. It's a crucial detail that doctors have to correct for to really understand what's happening. So we've seen that sickle cell is basically a quality control problem in our body's blood factory. But that factory can have other issues too. What happens if it's not a quality problem, but a quantity problem? Well, in conditions called myeloproliferative disorders, or MPDs, the factory literally goes into overdrive. The problem isn't the quality of the cells being made, it's that it's just churning out way, way too many of them. And then there's the flip side, myelodysplastic syndrome, or MDS. This is where the factory starts producing cells that are just defective. They're not built right and they can't do their jobs. It all goes to show you a healthy blood system needs that factory to get both the quality and the quantity exactly right. The story of sickle cell is such a powerful reminder of the delicate, intricate biology that keeps every single one of us alive. It shows how one tiny error in this vast genetic library can have such monumental consequences. And it really leaves us with this big, compelling question. What other incredible stories of health, of disease, and even of evolution are just waiting to be read in the code that makes us who we are?
So guys, that was an interesting one. Learning about that in hematology. I never expected to learn so much. So, but then it's amazing how far we've come. So we've been able to explore a lot of things, the power of Notebook LM and what you can do. So it just turned a whole book into a 7 minute breakdown, and you can also make it in podcast style. You made it into a mind map and also a 27-minute audio overview, and that's so much help to students. Imagine what that could do for you. Imagine the power you have in your hands literally with a tool like Notebook LM. That's the marvel of AI, the wonder of AI. And if you are not using it as a student or as a worker or anything you are doing at all, like, then you're making a huge terrible mistake. You should always use it. So if you're on this live, thank you so much for watching, and we're gonna end this here. I'll see you in the next stream. If you've not followed, click the follow button, like, and subscribe. So click the subscribe button.